Today we'll be talking about exponential functions. So the first question is, do you remember geometric sequences? So geometric sequences, those were something like, we started with a number, 5, we'll say, and then we multiplied it by something. We'll say we multiplied it by 4, 20. And then it continued that we multiplied by the same thing, so 4 again, and again, over and over and over again. Okay, when we were multiplying by the same thing over and over again, do you remember that we could have written this like the first term was 5, then 5 times 4, then 5 times 4 times 4, and 5 times 4 times 4 times 4, but we got a little bit more sophisticated and called that like 5 times 4 to the third, 5 times 4 squared. So it always looked like it was in something in this form. We had some starting number times some common ratio to a power, okay? Well, that's what an exponential function is. An exponential function, it's a function that can be written in that form, y equals a times b to the x, where a is a non-zero constant, okay, the starting value. B has to be greater than 0, but not equal to 1, okay, and x is a real number. So x can be any real number, it doesn't have to be an integer this time. So it can be any real number. And b, which would be your ratio, it has to be bigger than 0, so it can't be negative, but it can't equal to 1, because if it were equal to 1, and you started with a number, then you notice, hey, look, we just keep getting the same number over and over and again, and that would end up being a straight line when you graphed it. So that would be linear, it would not be an exponential function. So exponential function, y equals a times b to the x, a has to be a non-zero constant, and b has to be greater than 0, but not equal to 1. Okay. All right, so this is an exponential function, y equals 3 to the x. Even though you don't see like a little a value here, that could just be written as y equals 1 times 3 to the x. Okay, that would be fine. We're going to evaluate that for x equals 2, 3, and 4. So we've been given that x is 2, 3, or 4. So if y equals 3 to the x, that would be y equals 3 squared. Then y equals 3 to the third, and y equals 3 to the fourth. So we get our values of 9, 27, and 81. Okay, so that's just evaluating using your order of operations. You should be able to do that even if you hadn't learned today's lesson. Okay, this time I want you to try this on your own. P of q equals 3 times 4 to the q for the domain -2 and 3. Okay, and then come back and check if you're right with me. All right, so domain, remember that vocab, that's all your inputs. So that's going to be my values for q. So I'm going to try q as -2 and q as 3. So I just drew this second box in the table just so you can see how I'm evaluating it. A lot of times in your table you'll probably only have the 2 columns and not that middle thing. Okay, but P of q would equal 3 times 4 to the -2. So if I was working that out, that's going to be 3 times 1 over 4 squared, or 3 times 1/16. So P of q should be 3/16 for that one. If I try the next one, it should be 3 times 4 to the third, and in that case it's going to be 3 times 64, and that should give me 192. Okay, so P of -2 would equal 3/16, and P of 3 would equal 192. All right, let's think about a real-life problem that this could certainly happen, and it would be a situation that would be an exponential function. Okay, so suppose 2 mice live in a barn. If the number of mice quadruples every 3 months, how many mice will be in the barn after 2 years? Okay, so you have some strategies that you could use here. One way that you could do this would be like a table. So this would be like the months, and this would be the mice. And you could say, well, at the beginning, after no months, there are 2 mice. But after 3 months, that quadruples, so it multiplies by 4, and that's 8. And after 6 months, okay, now it's going to quadruple again, so it's going to be 32. And you could do this process all the way up until you get to 2 years, which is 24 months. But you may want to try to do a shortcut of coming up with an equation for yourself. So your equation, you know that you're going to start, so we'll put y equals, you're going to start at 2, and then you're going to multiply by 4 a lot of times. Notice to get to 3 months, we multiplied by it once, that's not a 0. It's like, hey, I wonder what this number is. To get to 2 years, that is 24 months. So if it quadruples every 3 months, we could divide this by 3 to say it's quadrupled 8 times. So I could put that in. It would be 2 times 4 to the 8th. And this is going to be a huge number. 2 times 4 to the 8th equals 131,072 mice. That's just after 2 years. So you better hope that you have something on some predator there that can get rid of your mice. Okay. So now let's graph y equals 2 times 3 to the x. So again, anytime that you don't know how to graph something, you don't have a shortcut or a technique, a table of values is always a great way to do this. So we're going to pick some values for x. I'm going to pick -2, -1, 0, 1, and 2. And then I'm just going to evaluate this function, y equals 2 times 3 to the x, for each value. So here I'm going to go 2 times 3 to the -2. Remember, that's going to be 2 times 1 over 3 squared, or 1/9. I get 2/9. Okay, the next time I'm going to do 2 times 3 to the -1, which just equals 2 times 1/3, which would be 2/3. And then I do 2 times 3 to the 0, and 3 to the 0 is just 1, so 2 times 1 equals 2. And then I'm going to do 2 times 3 to the first power, that's 2 times 3, and that equals 6. And then 2 times 3 squared, it's going to be 2 times 9, that's 18. Okay, and now I'm just going to plot my point. So -2 should be 2/9, so I'll see how accurate I can be. I'll just make an estimation. -1 should be at 2/3. 0 should be at 2. 1 should be at 6. And 2 should be all the way up here at 18. So you can kind of see those. It's definitely not a straight line. It looks like it's going to be increasing more and more rapidly. In fact, this is going to be joined by kind of a smooth curve, an upward curve, where it would look somewhat like this, as best as I can draw on this. So this is y equals 2 times 3 to the x. So table of values, they're your friends. Plug it in and try to solve it. All right, so let's check out one more problem. So the function f of x equals 1.25 to the x models the increase in size of an image being copied over and over again at 125% on a photocopier. And I want you to graph this function. So this time I'm not going to do negative values because you wouldn't be able to copy something a negative amount of times. So I'll start with 0 and I'll go 0, 1, 2, 3, and 4, I think would be good. Okay, so now I'm just going to do 1.25 to the 0. Okay, that will give me a value of 1. And then when I do 1.25 to the first, I think we obviously know that's 1.25. And then I'm just going to do 1.25 squared. And I'm going to do all these values. That's 1.5625. I'm going to do a little bit of rounding, about 1.56. Okay, and then when I take that to the third, I'm going to get about 1.95. It's 1.25 to the third. And then when I take 1.25 to the fourth, then I'm going to get about 2.44. Okay, so I want to come up with a kind of good scale here. I'm going to I'll go by halves. So that's going to be 1, 2, and 3. So this is going to be the scale, basically. And down here's the number of times that you've copied it. So we start off, and at the beginning it's just 1 times as big, and then 1.25, and then 1.56. So I'm going up ever so slightly. 4 is almost to 2. 3 is almost to 2. And 4 is almost to 2.5. So this, it looks almost linear, but it's really getting a little bit more steep every time, just by ever so slightly. It's going to look something like that with its smooth upward curve. Okay, so I think most of the stuff that we're doing here is just putting together a lot of things we've learned in the past. So hopefully this lesson will not be too bad for you, and we'll see how you do in your huddle.